All right, so 6.8, solving trig equations, except now we're gonna factor. So using factoring. So basically this is on your regular paper, okay? So you're gonna copy these down, and it's just 6 examples. So it says solve given that the answers are between 0 and 2 pi. So 0, yes, 2 pi, no, because that's not inclusive of 2 pi. Okay. So what do I mean by factoring? I will remind you, this is what I expect you to be able to do. Guys, factor something like that. So how do you factor something like that? Parentheses, parentheses, what do you get? What do you get? Don't just look at the paper. You should be able to do this, okay? You get something like that when you factor. All right, well, how do you solve that? If you need to use the X method, go ahead, but you should be able to factor that relatively quickly, all right? And then what happens after that, when you solve, you get a equals -1/2 and a equals +3. This is basically what we're doing, but we're using a lot of sines and cosines, and it's going to look a little bit different. But that is basically what we're doing. When I say factor, this is factoring, okay? So let's give it a try. So for number 1, you're going to write down 2 sine squared of x plus 3 cosine of x minus 3 equals 0. So it looks very different. I know it looks very different. So here's the first thing we have to do. We have to make it so that all of our trig functions are the same kind of trig function. So that's going to help us out, okay? So how do you make a sine squared into a cosine? How do you make a cosine into a sine? Well, we can't just change this into sine. There's no way we can do that. But you can change a sine squared into cosine squared by substituting 1 minus cosine squared x, right? So we know sine squared x plus cosine squared x equals 1. So you just go ahead and substitute it in, just like we did with all of our proofs. And then what do? You multiply it out. And then what do? You put it into an order that makes sense. So we want this to be positive because that's easier if this is positive. So this goes to the right side. This goes to the right side. This is a -1. It goes to the right side, and it becomes +1. Okay? So instead of 0 equals, I just wrote equals 0. Same thing. Okay. So if you can factor this, that's cool. But just for this first example, just for example 1, you're going to go ahead and replace, so you can really see what's going on for the first example. You're going to replace cosine x and cosine squared x with another variable. I chose n for Nancy. So cosine x is now n, and then cosine squared x is n squared. So everything is the same except I switched out my cosines for n's, okay? And then this, when you look at this, this should be much easier for you to factor. So you go ahead and factor that. And then you get 2n minus 1 and n minus 1. Yes, you're supposed to be able to factor. And then you solve for n, and you're like, yeah, I'm done. Are you done? Did you solve for x? No, you didn't solve for x. Okay, so n is 1/2, n is 1. But then what is n really? N is cosine. So really, cosine of x is 1/2, right? Because that's what we plugged in. And cosine of x is 1. Now we think about the unit circle. Where does that happen? Well, cosine of x is 1/2 at pi over 3, and over here at negative pi over 3, don't want to use negative pi over 3 because, look, we want positives, right? So pi over 3, and what is that, 5 pi over 3? And then cosine of x is 1 at 0, at 0 degrees, 0 radians. So we have 1, 2, 3 answers. Pi over 3, 5 pi over 3, and 0. So we list our 3 answers. Okay. And then let's try the next one. So the next one's going to be kind of similar, but, you know, maybe a little bit different, right? So let's see. So the next one, you have secant squared. So secant squared, again, are you going to change the secant squared or the tangent? Well, the tangent can't just change, but secant squared, we can use our Pythagorean identities, and we can change secant squared into 1 minus tangent squared x, right? So you use your hexagon, and then you're replacing, and then you get it into a good order so that you can factor easily. So that I would put on the right side this, I would put on the, oh, wait, what happened? Oh, why is that? Was that plus? This would be plus. Sorry. Let me think about my hexagon. Tangent. Oh, tangent plus 1. There we go. Okay. So really it was a positive tangent because it's supposed to be tangent plus 1 equals secant squared, right? So, okay, so plus. And then that's why it's positive, and then this is still negative, and then this is a 1 minus 4, which is a negative 3. Okay, so if you can do this part in your head, that's fine, but I'm going to replace my tangents with another letter. I used C this time. Do you have to use C? No, you can use whatever you want. But now for me, that's a little bit easier for me to look at and be able to factor in my head. So I factor, I solve for C. Is that my final answer? No, because really I'm supposed to solve for tangent of x. I'm supposed to solve for x. So I say those are equal to tangent of x, and then I think about the unit circle. So thinking about the unit circle, where is this true? This is true at 2 places, at 3 pi over 4, and what is that? 7 pi over 4. So I have 2 places where that happens. And then where is this true? Well, it's not on the unit circle. So my final answers are these two right there. And then here's my tangent inverse of 3. And then remember on our homework for the other day, we had our other answer in our calculator, but we don't have a calculator, so we have to write it down like this. So our other answer for tangent is always going to be whatever our answer is plus pi. So we go to the other side of the unit circle. Okay, so there's 4 answers here. There's not just 2, there's not just 3, there's 4 answers. Okay, example 3. So let's try this. So your first step is to, let's think about it. What could you do? There's many things that you could do. You could change this into 1 minus sine squared theta or sine squared x, but is that really going to help us right now? Not really. Okay, so how about like that? So, oh, I'm going to say something. I would think that maybe some people want to divide away cotangent x. If you divide away cotangent x, isn't it possible that cotangent x was 0? And wouldn't you be dividing away a 0? That's not okay. Another thing is, if you divide that away, then you're dividing away possible answers. So you can't divide something away when you're solving, like you can't divide an x away when you're solving for x, is my point, okay? So you got to keep them all. So my first step was to get everything on the left side. And then factor out. So right here, I made a little note. Don't divide away that cotangent x, okay? So you can factor out a cotangent x now, and now it's factored. So, you know, it's not this kind of factoring, but this is still factoring. You factor out something and it's factored. Okay, so cotangent x equals 0, and then cosine squared x equals positive 2, right? So minus 2 equals 0, so equals positive 2. And then right here, you're going to remind yourself, don't divide it away an answer, so you can't just divide that away, okay? Okay, so this, you're going to go ahead and keep going. What does that become? That becomes plus or minus root 2, right? So you take the square root, you get plus or minus root 2. Be very careful, plus or minus. Okay, so what happens over here first? Where is cotangent? Where is cotangent 0? Cotangent is cosine over sine. So where is cosine 0? Basically, that's the question. Cosine is 0 up here and down here. So our first 2 answers are pi over 2 and 3 pi over 2. So those 2 answers. Now I have to think about this one. So this one, it says cosine of x equals plus or minus root 2. What's root 2? If you plug that into the calculator, what's root 2? Isn't it like 1 point something? Like you don't have to know exactly, but isn't that 1 point something? How could a cosine, which is adjacent over hypotenuse, think about these words, adjacent over hypotenuse, how can that be bigger than 1? How can a hypotenuse, right, adjacent is smaller than a hypotenuse. Hypotenuse has to be the biggest side of a right triangle. So how can the hypotenuse on the bottom, if that's bigger, how can a fraction where the bottom's bigger and the top is smaller, like 1 over 2, 2 over 3, 3 over 7, how can it be a number bigger than 1? That doesn't make sense. So that part, it's not possible. It's not possible to have a cosine of x or a sine of x greater than 1. That's just not possible because sine is opposite over hypotenuse. Opposite over hypotenuse is a number over a number that's bigger. So hypotenuse is always the biggest side of a right triangle. So that's just not possible, okay? So we have 2 answers total. So sometimes you got to think about stuff like that. So that's the tricky part, okay? All right, number 4. So number 4, ooh, it starts off this way. If you can factor that, go ahead. So if you can factor that, go ahead. If not, go ahead and replace your sine of 3x, which is kind of crazy, right? It says 3x, but you're going to replace your sine of 3x with any letter. I chose M for Miriam. And this is something that you can totally factor in your head. So go ahead and factor that. It's just M minus 1 times M minus 1. And then you solve for M and you get M equals 1. Okay. M equals 1. But M is the sine of 3x. So you set the sine of 3x equal to 1. Okay. So you know how it's like a 3x and not just an x? So I highlighted it and I said, okay, we have to do something with that. Where does this happen? This happens up here. Where do you get a sine, a y value of 1? Up here at pi over 2. So that's the only place it happens. So, see what I did? 3x equals pi over 2 plus, this is a sine, so plus all the way around, maybe the other way, 2k pi. So now I have that plus 2k pi here. I need to solve for x still. So I'm not solving for 3x. At the end, I need to solve for x. Okay, so now I have 3x and then divide by 3 and I get that. And then I made it into a big fraction because I like to do that. And then I start plugging in. So just like before, you start plugging in. So you start with 0 and you get pi over 6. And then how many answers should I have, guys? This is my answer. It says 3x. I have 3 answers. So you plug in 0, you get that. You plug in 1, you get 4 pi plus pi is 5 pi over 6. You plug in 2, and then you get 8 pi plus pi is 9 pi over 6. What's 9 pi over 6? It's 3 pi over 2. You plug in 3, and if you plug in 3, automatically you get 12 pi over 6. 12 over 6 is, oh, wait, just kidding. If you plug in 3, you get 12 pi over 6, which is, oh, sorry, bigger than 2 pi already. And my answers are supposed to be way up here, smaller than 2 pi. Okay, so that's why plugging in 3 is already too much. So you plug in 0, 1, and 2. Okay, last 2 on the back. Okay, more interesting. Are you ready? Number 5. This one has a radical. Aww. We're going to have to do something with that radical. And we're going to have to do something with this sine and cosine. So we can't change the sine into cosine, but we can change the sine squared into a cosine squared. Okay? So we need to square this. But if we square it the way it is now, you're going to have a sine squared, you're going to have a cosine squared, and then you're going to have a sine theta, cosine theta. That's no good. So you want to take one of them and move it to the other side. It doesn't matter which one. I decided to move the cosine to the other side. And then you square it. So square both sides, tell yourself that you're doing that, and then actually do it. So when you square that, you get a 3 sine squared. And then when you square this, you get a squared minus 2ab plus b squared. So here's a and b, and then you just square that, okay? Okay, so wait, Miss Tan, how did that help me? Oh, because now I have a sine squared. What can you change sine squared into? You can change it into cosine squared. I do not want to see this arrow. I draw an arrow, but I do not want to see an arrow on your paper. I want to see you changing this into 1 minus cosine squared theta, and I want to see you multiplying it out, and I want to see you taking all of that and putting it on one side equals 0, and I want to see you factoring that. I want to see all the work for that for this section for 6.8, okay? I'm going to be looking for all of the work for that. Ooh, I know. I'm going to ask you for that in the homework helpline. Yes. Finish this part in the homework helpline, and then you're going to post that. Okay, I'm going to put it on the homework helpline today. Okay, so then you factor, and then you solve, and then I did that. Oh, why did I do that? Why did I do that? Because, oh, did I write it on the other side? I wrote it somewhere else. Okay, so you solve, but then this is not a right answer. So why is this not a right answer? I explain it over here, but here's why. Because when you squared these, you made them have more answers. So when you square an x, you get x squared. You're giving more answers than are possible. So sometimes you have these extra answers that don't work. So anytime you square both sides, you have to check your answer for extraneous solutions. So you do have to plug this back into either the original or this one, okay? But you do have to plug it back in to check that it actually equals 1. If you plug in 0, does it actually equal 1? It does. But if you plug in this, it does not actually equal 1. So you do have to check for extraneous solutions, okay? So somebody's going to post the rest of number 5 and then number 6. So I'll show you number 6. Number 6 can be done a whole bunch of different ways. I'm going to do it the shortest way possible, okay? What you can do is what can you do? You can change this into sine over cosine. You can change this into cosine over sine. You can do common denominators. You can do a whole bunch of stuff. But I'm going to show you what I think is possibly fastest way. So my fastest way, I'm going to go ahead and, move that cotangent. And then I'm going to think about something like that. If you want, you can write sine over cosine, cosine over sine. But what I'm realizing is, what I really have is, okay, now I can go ahead and cross multiply, and it says tangent squared theta equals 1, which means tangent squared theta equals plus or minus 1. Can you do this another way with sines and cosines? Yes, you can, but you're going to get the same answers. So in the end, where does tangent equal plus or minus 1? At those 4 places. Those are our 4 places. And then again, check extraneous solutions. Why don't we have any extraneous solutions for this one? Because we actually didn't square it. We cross multiplied. Well, did I? I don't think so. Well, kind of. Okay, fine. I should check my answers, but you can actually tell right here. So if I take that and then flip it, if I subtract it, I get the same thing, right? So if you flip it and just subtract it, so 1 minus 1, negative 1 minus negative 1, you get 0 each time. So you should check for extraneous solutions anytime you're like multiplying things into it, okay? Right here, you're squaring both sides, so you're multiplying things into it. On the front, we didn't actually multiply things into it. We just replaced. This already had a cosine squared. This already had a sine squared. This already had a secant squared. So nothing got multiplied into it. We just factored what we had. Okay? So you're going to give this, another look. You copied everything down. You're going to ask questions tomorrow. Number 5 is going to be on homework helpline. And then I think this is going to be our assignment for tomorrow. And then we're going to skip that because you're going to get lots of practice with this and you're going to do a really good job with it. Okay? All right. I'll see you guys tomorrow. I'll answer any questions you have.